Hi all, it's Juha from Ellie. Today we're going to take a deep dive into features of Ellie using a simple example. We'll walk you through the different sorts of features we have, how to use them, why to use them, and we'll see what the end result will be. Let's start with the very basics first. So, what is Ellie used for and why does it exist in the first place? The thing is that in the data world we have a problem where a lot of technical work is being done, but to a very limited amount of actual business benefit. And this focus on technology keeps kind of intensifying all the time, and we want to take that back a little bit. The idea is to reconnect this technical data work with the actual business needs and the requirements coming from the business that would actually produce real value. It is difficult occasionally to know what data we have, where, how it should be used, what that data means, and we want to make that work easier. When you are designing new data products, you're figuring out your data projects and initiatives, the need is there to understand how does this actually connect with my business. One of the things that we find many of our customers are finding problematic is that they don't have a common language between business and IT in the first place. Often the common language doesn't even exist between different business units. So this is also something we want to make easier for you. This is something that you have to figure out before anyone starts coding anything. Some of the use cases where this kind of thinking and Ellie as a tool might be of help to you are data warehousing projects, AI, ML initiatives. You might have just, simple BI reporting stuff going on. But you could also be building something completely different, like ERP systems, new processes even, where you still need to understand what the data actually is going to be and what do the words really mean. It's also very important to understand your data assets. Often this is a part of your data governance initiatives, that you need to figure out what data do we have in the first place, and what do you want to do with it, and who owns it, and what sort of rules and policies need to be applied to it. So it's not always about building new things, it's also about understanding what things already exist. Now, what Ellie does in this kind of problem field is that Ellie helps you figure out the data content and figure out the business structure of that data without going into technical details. The way we do that, the way we do this kind of business-focused data product design is that we apply data modeling methods and techniques in a way that is easy to approach and very, very fast. We also allow you to reuse all of this design, reuse all of these definitions and structures so that you don't have to do the exact same things and figure out what customer means in every single project that you do. Let's go into Ellie's basic parts, and after that I will introduce our example case for today. Now, Ellie is a rather simple tool by purpose, and the idea there is that we just have a few core components that you need to worry about, and these core components play together to give you that experience of easy business-driven data design. First of all, we have the data models, obviously. The data models come in two flavors. There's conceptual data models and logical data models. Conceptual data models, of course, are meant to help you understand your business, help you understand what things mean, how does the world actually look like, what is the structure of your data, without considering technical limitations. Figure out what the business is actually about, help you communicate with your business experts. Once you've done that, we have the logical data models, which are intended to be utilized in technical implementation design, where you are designing that, hey, this is the sort of data that I need to use for this kind of purpose, so I want to make this into a star schema, for example. So you design kind of a more technical structure to accommodate for the needs of your specific use case. These, of course, are linked together. In addition to the data models, we obviously have the glossary. Now, the glossary is the place where all those business definitions of these different things exist. So you have your customer and product and project and factory and payment transaction and whatever. And all of these business terms, these data elements that you have, that your business actually is built of, all of these are explained in the glossary. And they make the building blocks that you use to create your conceptual models, and they are also linked to the logical models which describe your implementation needs. Another important thing is how to use these parts, these glossaries, these models, when you actually then are done with the design and you want to move to implementation. Ellie has integrations. The idea is that we want to provide those data elements, those designs, those structures to you, whatever you're going to be doing with them in whichever tool. We have REST APIs. We will walk you through using some of those. And there are of course file-based exports and imports and so on and so forth. The idea is that the designs themselves, the models, the definitions, they should not remain just, as designs. They should also be utilized. And many of our technology partners and consultancy partners around the world are using these designs directly to generate things, generate code, use them in more technical data engineering tools to actually then build according to the design. And this is very important for us, so we'll walk you through some of those integrations as well. But now, let's head towards our example today. So what we're going to be doing today is walk you through all of these different features by using a specific example case. And our example case today is going to be that from a healthcare data warehousing project. Now, I've picked data warehousing and healthcare because those are things that seem to happen quite often. Ellie has lots of clients in healthcare space and many of them are doing data warehousing. But this could actually be pretty much any use case you can imagine. The core steps will be the same. But because data warehousing is somewhat easy to understand and well known in data space, and all of us understand something about healthcare, we'll just use this little example here to walk us through the features. Now, the basic problem setup in this example is that we imagine that we are a healthcare organization, let's say a hospital. Healthcare organizations have lots of different data, all of which is highly important to them. And this data is often spread around all sorts of systems and files and whatnot. And we need to understand how we're doing, how our patients are doing, how many of them do we have, what are we doing with them, and so on and so forth. The thing is that we want to gather that data from all different sorts of sources and put that into a single centralized place from which we could then utilize it for analytics and optimization and so on. Now, what we're going to be doing here is designing that central place. So we're creating a model that describes our data independent of the data sources to act as kind of the target model into which we want to build this. This is our data product. It's the data warehouse that we want to build. In the interests of time, our example is not going to be hugely complicated, but you will get the idea. Here are the basic steps that we're going to be doing. First, we will identify what sort of domain we're working in. This is a healthcare example. We will figure out a group of people that we would be engaging with. Of course, now we'll simply simulate that. And then we will start figuring out, all right, what is this domain actually about? What is the core structure of the data that we want? And we will start modeling that as a conceptual data model. After we've done the conceptual modeling part, we'll start figuring out what do the terms actually mean. So when we say patient, what does that actually mean? And we'll start writing those down so that we create the business glossary, which will be very useful to us later. We have the conceptual model, we'll create the glossary definitions to match the entities we've used in the model, and then we'll move towards the more technical implementation design with logical data models. Once we've done the logical modeling exercise, linked that with the conceptual models that we've created, then we'll see how those models can be utilized, taken out of Ellie. We'll use our API interfaces to deal with that. And then we'll share a few words about what comes next and how these models could be reused in the future. So what is kind of left behind as the result of this exercise. It's not just a one-off thing, we're building something that is lasting and beneficial for a long time, hopefully in many projects. First, let's start now with figuring out this domain. So we're in healthcare. We're interested now in patients and how they are treated, how they are diagnosed. So this is going to be the scope of our data product here. Now, normally we would then find the actual people who know about this scope. So we don't need just, engineers and architects here. We need the people who actually understand what this thing is about. Now, I'm not a doctor and we don't have healthcare professionals around today, but imagine this would be the case. So we gathered that group of people together to start sharing their understanding of what sort of stuff is going on and what do we have data about. And the important question here is, what do we have data about? It's not what data do we have in all these systems. We're not looking at the systems, we're looking at the reality of that domain. So imagine now that we've gathered this small group of people, we're discussing with them. Now we will jump into Ellie and start figuring out this domain with a conceptual model. So here we have Ellie open. Now this is our demo account. We have a bunch of models already existing. There's glossary items here. And we'll start with an empty model to figure out our domain with our business experts. So we'll start here with a new model, conceptual model for this business part of things. And this is going to be called our healthcare model. Now we have here an empty model, we have an empty canvas, and we find the search or create field here. And we have the bunch of business experts with us, and we start figuring out, all right, so what is this thing about? What things do you need data about? What are the important concepts, the important entities that we have that we want to be able to analyze? And our business experts in this healthcare area in our hospital, they will say, well, obviously patients. So we will type down patient here. And we will find out that the search or create field searches for matches in the existing glossary. I have created these entities already beforehand, so I can use what I've created, but obviously I could create new entities as I go. We'll use the patient entity here. We can drag that and drop that on the canvas, and then we'll add a bunch of other entities. They are also interested in employees, diagnoses, they're interested in treatment periods and so on. So I'll just add a bunch of entities here that we're going to be using in the model. All right, now we have a bunch of entities. I'll drag all of them to the canvas here. And we figured out that, okay, we need data about patients, employees, treatments, and diagnoses. So how does this actually work? How are these things related to each other? So what our experts now tell us is that, okay, well, a diagnosis is obviously performed to a patient. So we will link these two entities. This is a simple click and drag thing. So we click and drag our relationship there. It automatically creates a one-to-many relationship between patient and diagnosis, which is good for us here. Obviously, we could here also change the relationship type to something else, but we will use this for now. So patient has multiple diagnoses over time if they happen to have different sorts of reasons to visit the hospital. And we can describe here how this relationship actually works. So we can write a relationship description. Patient has a diagnosis or multiple diagnoses like this. And then we also want to know that who actually did that diagnosis work. So employees are going to be involved. We will just add a relationship here between employee and diagnosis, saying that the employee does the diagnosis. So the diagnosis is done by an employee. There we go. So now we've figured out diagnosis. There's also a classification of diagnosis that we have to worry about. So there's always some sort of a reason, some sort of code for the diagnosis, and that comes from an official diagnosis classification. So we will link that entity here as well. And we can say now that every diagnosis is always coming from this diagnosis classification, and there's only one kind of classification code for each diagnosis. So that's why we create one-to-many relationship here. Another thing that we're interested in is how the patients are treated. So we'll add a treatment period here. There is a period during which the patient is being treated. And our experts tell us now that, okay, there's actually how this works is that there's a period during which they are in a hospital or something, and during that period they get multiple treatments, or one or many more treatments depending on the nature of their illness. So we link treatment period with treatments. We see that, okay, for each period we can have multiple different treatments, and obviously it's the patient that is being treated, so we will link those two together like this. And then we also need to figure out who is administrating the treatments. So we are now interested in the employees. They are doing diagnoses, so we also want to make a relationship between the treatment and the employee, so that we can say that the treatment is administered by. There we go. And then, now that I mentioned that the treatment periods involve hospital stays, this is a thing that our experts tell us, that they also want to know where these people are being treated. So we add hospital. But then our experts say that, there are not just hospitals, we also have different sorts of locations in which these treatments are being given. This would usually involve all sorts of discussion on various classifications of different kinds of facilities. But for simplicity's sake here in this example, I'm just going to be using an entity called other facility. And we're going to be modeling this so that the treatment period happens in hospitals or other facilities, and we will use a supertype structure here to denote the fact. So we'll use a kind of general entity called service location, and we will simply drag these entities inside that, so that we can say that all the treatment periods happen in a service location, which might be a hospital or other type of facility. There we go. Now, a couple more things. Our experts now say that, well, because the diagnoses are always classified according to an official classification, that also goes with treatments. So you can't just invent treatments. We need to have a treatment classification. We add that. And to also control for costs involved in this process, we'll add a cost center. And our finance experts perhaps might say that the cost center is always assigned to a service location, so we can link these two like that. One more thing remains in our model, and we suddenly realize that, hey, actually, patients and employees can occasionally be the same thing if an employee falls sick or has an accident. So we will create a generalization of the persons being patients or employees. So we have a person entity, and we'll create relationships with the patient. And this is going to be an optional relationship, because a person can be a patient, or it can be an employee, or the person could be both at the same time. So we'll create optional relationships like this to denote that the person can be a patient or an employee. And there we go. Now we have modeled the healthcare problem area that we want data about. This is, as I mentioned in the beginning, in the interests of time, a limited scope, but it already captures quite important things about our business domain. Now we know who is being treated, who is being diagnosed, by whom, in where, and how do the costs occur to different cost centers. So this is already quite powerful model for all sorts of healthcare related analytics here. And this we do without looking at source systems. Obviously, we could have people involved in this modeling session who would already know that, okay, well, we don't have that kind of data at all, or we don't record how cost centers are linked to service locations or something, which would help us create the model from the perspective of existing data in the systems. But we're not building the model based on any systems, we're building the model based on how the business operates, and that's why we need to identify the actual subject matter experts and involve them. Now, one thing is missing before we jump into implementation design, and that is the definition of what these entities actually mean. And I'm going to show you just a quick example. Let's have a look at the treatment entity. So I double click on the treatment here, and I'm taken to the glossary page of this entity. And here I've written a description. A treatment is a single operation performed on a patient during a treatment period. All treatments are classified by a treatment classification code. And this is actually what our model already tells us. There's also other kinds of metadata that we could add here. We could add examples, synonyms, source systems, various things. These are also customizable in Ellie. And now the thing is that these are metadata items about the treatment. So the treatment has been defined as such, and that can be reused across different sorts of models. For example, we might compare this with the treatment period, where we can see that a treatment period is defined as such, and this is a different thing from a single treatment. And this difference between different entities is often very important for us to communicate, because the next guy who comes and models these things has to understand what these things actually mean. We can also have attributes here, and here we can see that for a treatment period we have a start date, end date, the service location, patient ID, so we're recording who is being treated where during which period. Another thing that we might be interested in is the relationships between entities in different models. So let me just quickly show you how this works with the employee entity here. First of all, we will see that the employee has not been defined, and this might be problematic for us because we haven't considered, for example, contractors at all. So this would be something that we do during the session, that we come up with a definition of an employee. We can refine that later, but one thing that might help us define that is how the entity is related to other things in different models. So we have the relationships tab here, which automatically shows you every single thing where the employee entity is being used. And now I can see that we have 4 models in this account which use the employee entity, and these are the different sorts of relationships that the employee has with other entities across all these models. So we could check, for example, the HR model to see how we've defined the employee there. And here we can see that employees belong to teams and they have employment periods and so on, job titles and that, so on and so forth, which might help us define what the employee actually means. And we might want to consider that when we are using the employee entity in our model here. This is how all these entities link to each other in Ellie. Everything comes together around the glossary, the shared entities between the models. So it's not just a diagram, it's a linkage between all sorts of different things. Now let's move to the logical model. There are different ways of doing logical models for different purposes, and for the sake of this example I'm just going to be creating a rather simple logical model. But obviously we would be creating logical models, we would define the sort of model we want to create. It might be data vault, it might be third normal form, it might be a star schema model. We define what sorts of entities we have there, what sorts of attributes we have there, primary keys and foreign keys, and then we start linking those logical entities with the conceptual entities so that we know what the data actually is about. And this is what we're going to be doing now. Let's create a logical model. So we start with an empty model here. This is our healthcare logical model. And as opposed to the conceptual modeling canvas, here we do not have the glossary, because the glossary contains business entities. Now we're talking about kind of implementation design. So we start from scratch and we decide that this is going to be now a star scheme. We can imagine that we would have a data vault model for our actual kind of storage layer in the middle layer in the data warehouse, and now we would be perhaps modeling something for a data mart or something like that, or we could be building our data warehouse on the Kimball method. But in any case, we're going to be using star schema as an example here to show you how this works. We have an add entity button here, and we'll simply start adding different kinds of entities. We'll start with the fact entity in the middle of the star scheme. So this is going to be our treatment fact. Now we're analyzing how treatments, what kind of treatments we are doing, who is doing treatments, and so on and so forth. So we want to have our fact about treatments, and I will now type in a few attributes that we are interested in our fact table. There we go, a bunch of attributes. Now I can also link this logical entity describing our fact table with a business concept. And that is done with the glossary link in the bottom part of this view. Now obviously this is about treatment, so I will link this with the treatment entity. And here again, we are searching from the glossary for matching entities. We will use this. And there we go, we create our fact table. Now, what I didn't do yet was define any primary or foreign keys, and I will do that in a moment. Let's create a dimension table or two just as examples here around our fact table. Now we have a patient dimension, and because we've identified that for patients we have a patient ID as the primary key, we can also mark that we have a relationship between these two tables, and here in the fact table the patient ID is a foreign key. Now we can obviously then go ahead and mark the rest of the keys. I will just do this as an example now, but we can figure out what are the keys for our fact table, the primary keys, and what sorts of foreign keys are around it to link that with all the different dimensions that we have. And now I will just simply add a bunch of other dimensions around this. We need the employee dimension to analyze who is giving these treatments. We need the location dimension to figure out where these treatments are being given, the treatment classification, and then of course usually in this star scheme of things we also want to have a calendar dimension to understand when these happen. So I will just simply add all of these now. One thing to note here about this employee dimension is that we also want now to have information about the team in which the employee is working and the department in the same dimension. So we can simply link this dimension entity with multiple business concepts so that we realize that, hey, here we actually have data about more than one things. And there we go. Now we've defined a star schema with a fact table about treatments and a bunch of dimensions about different things, and all of these we've done based on the information we got from our conceptual data model. So we have been able to link all the tables, even though they contain data about multiple different things, with the business concepts, the entities in the glossary, so that the next person who comes over and looks at this model actually understands what do we have in the location table here. This now acts as our implementation design for our developers. Please create a data mart that looks like this, containing data about these things, given that the data itself looks like what we have in the conceptual data model. So we've built something from the business perspective, starting from the business concepts and going down into this technical, more detailed view of the specific kind of data solution we want to have created. Now, as a final thing before we wrap this up, let's see how these models can be utilized. So what I'm going to do now is show you how the Ellie API for model export works. Ellie has a bunch of different sorts of API endpoints, but we'll use the simple model export here to show how these designs can be taken from Ellie and utilized in other tools. I have now admin level access here, so I have the API settings available, and here I have created an API token. I will delete this later so that you won't be using it to access my models, but we will be able to use this to authenticate against Ellie's model export API to grab those models out of Ellie, and I will be using Postman as an application to do this. So I'm simply copying the API key here, and we'll check the model ID we want to use. You can see the model ID here, but it also shows up in the URL of that model. And now I will jump into Postman to utilize this. So here we have a Postman just for checking what the API output looks like. We have a simple get call. This is all documented in the API documentation of Ellie. We add the token here and we check the model ID. And there's our URL for this API call. We'll simply click send. And what we get back will be the whole description, the entire model, all the entities, all the attributes, all the definitions, all the relationships from this particular model. And now I used here the conceptual model, but this can also be done for the logical model with an exact same call, just switching the model ID. What we see here is a JSON file coming as an output of that API call, and we see that there's the basic information about the model. We have all the entities here, all the attributes of those entities, all the metadata of those entities, and in the end here we will also have the relationships between different entities. So we can see here, for example, that we have a relationship in the model between service location and treatment period, one to many, and there's the description of that relationship as we defined in the conceptual model. Now, this could be used in all sorts of different tools. You could generate things based on it, generate code, generate database diagrams. Most often that kind of work would be done with the logical model, but there are applications and use cases where the conceptual model is directly utilized to generate actual solutions for the data warehouse. Another use case for this would be to map these concepts, map these structures with your data catalog so that you could see that, okay, I have the employee entity and that is implemented in these kinds of physical data sources in my catalog. So you could just simply export this whole structure and link that in your catalog with other things. But this is just one way of utilizing the models in Ellie in other tools. One last thing here that I want to mention is the reusability of this. So we've created models, we've created definitions in the glossary, we've created export files, JSON files that we got through the API. What if we have another project coming up and we want to do something that is similar but not entirely the same topic? So we have the models in a central repository here in our Ellie demo instance. These are not just one-off diagrams, we can utilize them over and over again. What usually happens is that you have more projects around the exact same topic. So you can use the conceptual model in those projects as well, because your business didn't change between projects, most likely. Your technical implementation scope might change. You use the exact same conceptual model to understand how this works, and you create new logical models based on the needs that you have in your future projects. That is of course possible. But then you might have something that you want to expand this model already conceptually, you need data about more things, or you want to modify something. You could easily just create a copy of this model and then modify that to your needs by adding more entities or focusing on some different area of that model or so on and so forth. What happens is that all these entities we've created end up in the glossary, and these are the reusable building blocks that you have in all your future models. So the glossary becomes a repository of things that you want to reuse, things that you want to check occasionally, that if you have entities that you are not sure of, what does customer actually mean, you can always come here and recheck that and then start modeling away again. And there we go. This was an overview of all the different sorts of features we have in Ellie, how to use them. We utilized a healthcare data warehousing example here. If you have your own ideas on how to use Ellie, you want to try it, we have a free trial available at Ellie.ai. Let's be in touch. Thank you.